Right, so today we're going to do an LS430 2000 to 2003. This one's a left-hand drive vehicle and a manual gearbox. So let's get into it. Right, so as discussed, it's an LS430 2000-2003. This is going into a left-hand drive vehicle, so you can see the harness coming out this side, and it is using a manual gearbox. You see we've got no gearbox wiring at all on here. Right, so as it's a brand new built harness, like all our 3UZs, to bring everything inside the vehicle rather than living in the engine bay, because these are not waterproof. First thing we're going to do is we're going to go through the whole build process so you can see exactly what it entails to build one of these, what it looks like underneath all of that heat shrink. So we'll do that now and come back in a second. Right, so now you've seen what it looks like underneath and what the build process is and what we do with all these harnesses when we do them. What we're going to do now is it's going to be broken up into two sections. So we're going to have a layout section where I'm going to go through the entire harness and you can see where everything plugs in and how it should be routed. Secondly, then we're going to have the testing section. That's going to involve doing a couple of tests just with the ignition on and actually running the engine as well, so you can see that everything works exactly as it should. So to start off with, on the layout side, what we're going to do is we're going to start at the ECU end and work our way over there. First thing I'm going to do is explain the connectors on the fuse box that the customer will need to connect into their vehicle, so you can see exactly what it entails on your side when you receive your harness. Right, so with every harness you do get a welcome pack, and this details all of the connectors down here, where they connect to, and some useful tips on connecting them, things that I've come across that people might come a cropper with those. Okay, so in this case you've got your 9-pin plug, which is pretty standardized now. We've managed to keep it standard across the whole range, all the way from 1UZ to 3UZ. And then you've got your 6-pin plug over there, which is mainly your diagnostics and one other wire. So I'm going to start with a 9-pin plug. Really nice and simple. They're all color coded, so you don't have to worry about mixing anything up. 9 and 6-pin plug cannot plug into each other, so again, no need to worry about mixing those up. So first of all, pin number 1, it's a red 14 gauge wire. That is permanent 12 volts. You'll see I've said there, permanent 12 volt supply. Now, the ECU does retain a memory. It helps with diagnostics. And I actually have a video up at the top there about doing diagnostics and explains how important that permanent 12 volt is. So please remember to connect that to a permanent 12 volt source, not an ignition 12 volt source. Pin number 2 is a black with a yellow tracer. That is your start signal. So that is a 12 volt feed to the fuse box to start the actual engine itself. Now obviously there's a starter relay in there. That little 20 gauge black and yellow wire is just controlling a relay, so don't stress about making it thick. It's just to go at the back of your ignition barrel, or if you're going to use a button to start your vehicle, no problem at all. 12 volts on one side of the button, out the button to the black and yellow wire, and that will then start the engine up. Number 3, yellow with a green tracer, that is the gauge temp. So you'll see when we come to the layout, there is a wire here that's hanging loose called temp, and that is so you can put your own temperature gauge in or send it in for whatever gauge that you want to use. All right. Then number 4 is gray. It's a 16 gauge wire, and that is for your fuel pump. So that's the 12 volts for your fuel pump. It is controlled via the relay. Also, in this case, it is controlled via the ECU. I do have a video on fuel pumps for Toyota and Lexus and how they work, so put a link up in the top there if you want to have more in-depth information about that. But just note that the ECU is controlling the fuel pump in this particular case. And most importantly, if you don't watch that video, these don't prime. So don't be scared if you plug everything in and you don't see the fuel pump going on for 3 seconds when you turn the ignition on. Completely normal for Lexus. Don't stress about that. Number 5 is yellow with a red tracer, and that's your check engine light. So in your vehicle, normally on your dash, you'll have a check engine light. That wire is to power that up. It gives off a ground. So if you're going to use an LED as a check engine light, if you're going to retrofit one, then just remember that that is a ground. Other side of the LED to 12 volts, other side to the yellow wire with a red tracer. Number 6 is a straight yellow, and that is your tacho signal. So that's the signal from the ECU given out to run a tachometer. Now bear in mind, this is what we call a low level signal. So if you had a cluster or a rev counter that required a signal from like an igniter, that's a high level signal. This one won't go directly in. Usually there's a resistor at the back of the rev counter that you need to remove in order for it to receive this signal. Secondly, this gives off a 4-cylinder signal. So it's a bit of a kind of a legacy thing left over from the 3UZ. They used to have 2 banks with 2 different igniters, and they used to use one of the igniters as a rev counter signal. So it happened to be a 4-cylinder. They just carried that on all the way through the 3UZ, even though the rev counter signal actually comes from the ECU now rather than an igniter. Okay, so that is the yellow wire. Then we have number 7, which is black with a red tracer. Now that is your ignition feed, so that's how you turn on the system. Now if you are using an ignition barrel, something I must stipulate that I've seen many times, believe me, is people go to the ignition barrel, they find a 12 volts that comes with the ignition on, they connect it up and they go to crank it. And what they've done is they've connected it to the accessory feed. So the moment you move to the start position, it cuts power. So your whole ECU and everything turns off, and then it won't start. Okay, so just make sure that you double check that when you're looking for a 12 volts behind an ignition barrel, that 12 volts stays 12 volts even when you move the key to the start position. Okay, just something to know that I've seen it quite a few times. You'll be surprised. All right, then number 8 is your pink with a blue tracer, and that is your charge light or alternator light. So in this case, I've got it hooked up to an LED over here. Obviously these are digital gauges, and they used to get their alternator signal from the ECU, etc. Anyway, that's besides the point. It is a negative feed, exactly like the check engine light, and you can use it to run to your dash if you have a battery or a charge light in there, no problem at all. One caveat is that if you gauge uses an incandescent bulb, it can back feed through. So if that is the case, 2 options. 1, fit a diode between my pink with a blue tracer wire and your input for your alternator light. Second option is change the incandescent bulb for an LED. Does the same job. LED is a light emitting diode, so it does the same job as fitting a diode in the line there. So that's usually the easiest option that you've got there. Depending on your cluster, obviously, you can't assume that all clusters would have an LED replacement bulb for that. All right. Last one is the yellow with the black tracer, and that is your oil pressure. So again, it's just coming from the oil pressure switch on the engine. Straight, simple, grounds out when there's no oil pressure, loses ground when there's oil pressure. So again, you can run it to the dash, you can run it to an LED if you want to, but remember, other side of the LED 12 volts, yellow and black wire is the ground for that side of the LED. Okay, in our particular case here, I've actually got it hooked up to our little MPX device, and that is going to be transmitting the oil light to the dash there for us. Okay, so that's how we're going to be checking that particular section. We also feeding the yellow with the green a gauge temp to here, and that's going to give us our temperature on the dash as well. So that's how we're going to make sure all of those wires work just fine. All right, moving over to the 6-pin plug, there's really not much to see here. The first 4 wires are purely related to your OBD2 connector, so they come straight out of there and into there. There is one other wire there, and that is your white with a blue tracer, and that is a brake switch. So again, nice and simple. It just requires a 12 volts when you press the brakes. We do use a relay to take care of the more complicated Toyota system. It was like a 4-wire switch, so it had power when there was not being brakes pressed, and there was power when the brakes were pressed. So we take care of that. All you need to do is just tap in to your brake light switch feed, aka the wire that supplies your brake lights with 12 volts. It is all fused in here, so don't stress. You're not going to be able to short out or create a blow and blow up the ECU. All taken care of in the fuse box for you there, nice and safe. All right, now Gerard, in this case, he wanted a little bit extra. He wanted to fit some oil pressure and possibly temperature sensors. So if you come along here, you'll see that we've got a little plug over here. Now, when I go through the layout, you're going to see the other side of that plug. In our case right now, we've only got just the oil pressure switch coming out of there, going to there. But once Gerard has everything set up and he knows exactly what he wants, he's going to be able to pull that out and then add in an oil pressure and an oil temperature sensor and just connect it to whatever gauges he's going to use inside the car directly from here. So really, really nice and simple. So again, guys, these are things we can add in if you want. You just need to have a conversation with us from the get-go. We can add in as many wires as you want from there, even if it's something that you want to use further down the line. So everything is open for discussion. These are all brand new, custom made, so we can add in things willy-nilly, no problem at all. Right, so now that we've gone through the little connectors over there, we're going to go through the layout, and I'm going to start at the ECU end over here. So nice and simple. You've got your 3 plugs there, your 2 plugs there. Coming out here, you've got your pedal plug, so that's coming along and going all the way along there to there. So that is absolutely fine. Nice and easy. We make it 2 meters long, so you should have plenty of room to run it along the firewall if it's got to go up and down sections to come neatly to the pedal over there. All right. Also coming out of here is one of your fuse box plugs. So that is a 12-pin plug over there. The other one comes out over here, and that is an 18-pin plug over there. All the plugs around the fuse box are completely differently keyed with different numbers, so you can never get it wrong. So please don't stress about that. You can't get the wrong plug in the fuse box over there. All right. Moving along to here, and then we have our grommet over here, and that is sealed with some SCL heat shrink over there. Okay, moving further along here, we then get to our breakout T-piece over here, and that's where it splits up to go around that way and around the front over here. So in this case, as left-hand drive, we're going to start going along here, and then we'll come and go along that way over there. Right, so in this case, first section of the breakout over here, we're going to have coil 8. So you can see everything is labeled. It says IGN 8 there. Then we come further along to here, and then we break out for the cam sensor over there, and also ignition 6 and ignition 4. So remember, with these engines, this is the right bank. So you're looking from behind. This is the right bank. That is the left bank. This is going to be the even cylinder. So 2, 4, 6, and 8. That's going to be the odd ones, 1, 3, 5, and 7. Okay. So ignition 6 and ignition 4 and the cam sensor come out over here. Then it comes further along here, breaks out over here, and it goes to the coolant temp sensor. So that's your 2-wire sensor for the ECU that goes in there. Then this is your temp wire. So this is the wire that's going to go in there. So in the moment, you see I've got my little single wire Toyota temp sensor in there. It's just so that I can test it on that one over there. Coming out here also, we've got our oil control valve for the right bank. So that is over there as well. We've got our ignition 2 coming out there. And then lastly, for the bit that pops up, well, second lastly for the bit that pops up there, we've got our throttle plug over here. So again, we put these on a separate little sub harness here. So it makes it easier for when guys have 5-speed or 6-speed throttles, as well as if guys want to go aftermarket further down the line and they want to fit a different throttle body altogether, all the wires are in there for every modern sort of drive-by-wire throttle body that you might want to use. So you can just unplug that, plug in another one, do a patch harness for an aftermarket ECU, and away you go. All right, then also coming out here, we've got the mass airflow sensor. So that's plugged into there like that. So do make sure with the 3UZs that you do get the right mass airflow sensor. If you guys ever need, just let us know. We'll give you the part numbers for your exact model. And in regards to that, most of the time, if guys are buying engines from scrapyards, you may end up with a different engine with a different ECU. Don't ever stress. Make sure that the mass airflow sensor matches the ECU. If you've got your part number there, you can stick it in a Toyo DIY, go to the airbox section, it'll tell you what mass airflow sensor to work with. That's by far the easiest and simplest way of taking care of that. All right, so that is your MAF sensor over there. Then the harness breaks out and comes down here. Okay, and then it breaks out at the bottom here, and that's where it splits off to go to your alternator. So again, we've put the alternators on a sub harness. As discussed in a lot of previous episodes, if you ever want to swap out the alternator, and you can only find the later 6-speed generation ones from like a GS or an LS430, obviously you can just phone us up and we'll make you a little sub harness that'll plug into the 4-pin plug of one of those. Just be careful, the Crown alternator is different. So the Crown UZS186 does actually utilize all 4 of the wires, whereas the LS and GS 6-speed, although they changed over to the 4-pin plug, they didn't utilize all of the 4 wires. It's actually only 3 out of the 4 connected in there. And then lastly, coming down here, we then have our Lambda sensor. Now, I've just plugged this in for the layout section, but you would normally have your Lambda plug sitting in there, and you'd have a much longer lead on your Lambda, okay? You can't use these short ones like on the other side. They have different wiring from the longer ones, so just bear that in mind when you come in to replace Lambdas. On a 3UZ, they are different for each of the banks. So the right bank and the left bank main Lambda sensors are different parts with different part numbers. Right, so now we've done this side over here, we're now going to move over and start making our way around there. I'm just going to do the sections that come out here, and then I'm going to jump around the other side and we'll carry on from there. Right, so nice and simple. The first 2 that break out there is going to be your 2 grounds. One's for your coils and one's for your engine harness. They're just going to bolt into the hole over here. There should be an M6 bolt in there that you could use or should have from your existing harness. That's where that's going to go on to. Right. Coming along, we have the injector sub-harness, or injector ACIS sub-harness as I like to call it. So this is the one that goes underneath the intake. It then pops out for all of your injectors. I do have a video on how to install that. So if you watch this before you install, give that a watch in the top corner there. That'll show you how to install these harnesses, because it is a process. You need to pull the intake off. So as you're doing the other harness that goes to the NOx sensors, you can do this one at the same time. Okay, so that's the injector and ACIS harness. Next up, we've got our sub harness. So this is the one going to the NOx sensors and the starter solenoid. Now, remember, you do have your main thick cable for your starter solenoid, and then you have your little plug for your starter solenoid. You have your main plug for your starter motor, then you have the little plug for your starter solenoid. So don't get them mixed up. This is a whole harness that goes underneath there as well. If you wait till the end, you'll see the photos of what it looks like underneath there. Everything is labeled, so NOC 1 and NOC 2. So we label them as per the bank. So obviously NOC 1 goes on that side, NOC 2 goes on this side. Okay, so when you come to install those, that's what it looks like underneath there. All right, so those are all the sections that pop out of here, out of the T-piece, molded T-piece. Then the harness just moves along here. Now, usually if you've got a 3UZ, you might have some mounting holes along here. You can put a little P-clamp there and mount it over there. You're going to come to a breakout point over here. And first of all, this is your ground for your coils. And again, that's going to go in the other M6 bolt that you should have in your block if it's a 3UZ, because that's what the 3UZ used to use as a ground point on there. Now, that's as far as I can go by leaning over. So first of all, I'm going to move around the engine. Right, so we're back again. So again, this is your ground that's popping out over here. You can have it popping out this way, that way, whichever one looks nicest. It is the back, so you can't really see that over there. Right. On the other side of that, we've got ignition 7. So that's popping out over there. So again, everything is labeled nice and easy for you along there. This is going to come along here, and it's going to break out over here, and that's going to go to your cam sensor for the left bank. It's also going to go to ignition 5 and ignition 3. So those are the 3 sections that break out over here. Then coming further along here, we're going to break out at the front here, and that's going to go to coil 1 or ignition 1. It's then also going to go to your oil control valve for your left bank. All right. It also breaks out for the cam there, but we try to minimize the amount of breakouts because it just makes it look a bit neater. So if you come along to here, you'll see there's a mounting point over there. So you can put a little clip or something to hold it down over there, and that'll keep that in place. Then it comes down and goes into your front cam sensors. You'll notice on the 3UZs and the 1UZ VVT-i, you've got the 2 cam sensors monitoring the inlet cams, because that's where the VVT-i is. And then this one is just a single tooth cam sensor that's doing synchronization for the engine itself. All right. Also coming down here, you're going to see you've got mounting holes there and there. So you can clip the harness out of the way over there. And then coming down there, this is where your breakout is, and we're going to go off into a couple of different sections. So we're going to go through those now. So in this case, you've got your Lambda sensor, which goes along there, sort of keeps it over there. So usually on the standard ones, they bring the Lambda plug down here. Obviously brings it really close to the exhaust. In this case, what we do is we tuck it away so you don't have to have it anywhere near the exhaust, and you can keep it nice and heat free. Also coming out here is the oil plug that I was talking about. So in this case, the customer wanted to add in an oil pressure and temperature sensor that he was going to run on his separate gauges inside his car. So effectively what we've done, we've put our sort of standard modular 6-pin plug for oil, which gives you 3 wires for an oil oil pressure sensor. So you've got 5-volt sensor, ground, and oil pressure. Then you've got 2 wires for an oil temperature. So again, the oil temperature and a signal ground. Now, bearing in mind, these are sort of the standardized connections for those particular sensors. So whenever you have a gauge inside the vehicle, usually the sensor would require 3 wires for oil pressure, 5 volt sensor ground and the signal, and oil temp would usually have 2 wires, sensor ground and the signal going to the gauge. The 6th one in here, that is just the oil pressure switch. So that is what we currently have just in over here. So that is going to go down. That would normally tuck inside here, pop down into there and go into there. All right, now remember you do have a couple of different oil filter housings on here. So if you have a GS one, it would go over here. If you've got LS one, it's going to go over here. Same with the SC, also the backward facing one, because they have 2 front sumps over there. No, they don't have 2 front sumps, they have a front sump, both of those. Right, then lastly, breaking out here and going out and in through there, down through there is your crank sensor. So that is plugged in over there. Okay, so that's pretty much the entire harness. So like I said, the only difference between a standard one and this particular one is we've now added in the ability for the customer at a later date, whenever he's ready, to add in his oil pressure. And that is why you'll see on his particular connector pinout, we've labeled on the auxiliary connector for the oil exactly where everything is over there. So Gerard, that's all the information. You'll get that through via email. Well, obviously when we're done here, we packed everything up before we send it out. Right, so that is the layout of the harness. So what I'm going to do now is we're going to get the engine up to temperature, just so that you can see the coolant temp on the gauge, because that's obviously part of the testing that we're going to be doing. So just help not having to run the engine for 25 minutes, so you can start to see the coolant temp pop up there. So I'm going to head off and do that. And once I've done that, we'll be back and we'll start doing all the testing. So bear with me. Right, so now we're going to get into the testing of the harness here. So it's going to be in 2 sections. One we're going to do with just the ignition on, so we're testing some sort of signal lights like alternator lights and check engine light and all of that type of stuff. And the second is going to be with the engine running itself and doing a whole bunch of tests there. So I'm going to break down for you the 2 sections, what we're going to be testing, what we're looking for, and then we're going to jump straight into it. So in terms of with the ignition on, as I said, nice and simple, we're just checking things like the check engine light. So we want to make sure the check engine light comes on the fuse box there. We've also got our yellow with the red wire connected to our dash over here. So we're going to make sure that that lights up as we expect it to. Oil pressure light, obviously it's already on because it is supplying a negative automatically to the device, and the clocks have a permanent 12 volts. So what we're looking more for is that it's going to go off when we actually start the vehicle. So that's going to be what we'll be checking there. Alternator light. I've got my little LED over here to replicate the alternator light. You see it's attached to the pink with the blue tracer wire over there. OBD2, we're going to go over to our machine, make sure that it picks up the ECU and takes it as an LS430. So we'll check on the system over there. Fuel pump, because the fuel pump is controlled via the ECU, we're going to use our machine to actually test the fuel pump. And then I know that everything from the ECU communicating outwards is working absolutely fine. And obviously our fuel pump is connected to the 9-pin plug over there, as where the grey one should be. Right, then we're going to move on to actually starting the engine. Then the first thing we're testing is obviously the starter circuit. So I'm going to give the black with the yellow tracer wire 12 volts. The starter motor should kick over and the engine should fire up. So that's what we're testing there. The ACIS is the next one, so that's the acoustic control induction system. So we're looking for this little valve at the back here to close. Now I do have a video going into much more detail about exactly how the system works and what it does. So I'll put a link in the top there for you guys, so you can go and see that as well. All right. Then we're going to look at the tax signal. So we've got our little device here that's translating for our IS200 dash. So we've got our RPM signal going into there, and then it's being translated from a 4 to a 6 cylinder and coming out to here. So we should have an accurate reading on our rev counter over there. Coolant temp, exactly the same thing. So this is in relation to the single wire temp sensor that we include in the harness. It's currently connected to a Toyota single wire sensor over there. So we should see on our dash a coolant temperature sensor go up there. That means that our yellow with the green tracer wire is connected properly to the harness over there. So that's what we're testing over there. Drive-by-wire, it's nice and simple. We're literally just going to rev it. Remember, a 3UZ is a complete drive-by-wire system. There are no cables to the throttle body. It's not a hybrid system like on the 3UZ-FE VVT-i. So as soon as I rev it, the throttle should go up and the engine should rev absolutely fine. VVT-i solenoids, these are the oil control valves for each bank. So the machine allows me to test both of those. So we're going to do that. It's going to then retard the cams. It's going to sound a bit lumpy, and then as soon as they go off test, it's going to go back to normal again. So that's how we know that it has worked. And injectors and coils, again, nice and simple. We're just going to pull each injector off one by one. That's going to show us that each cylinder is firing as it should do. Now, the reason I do injectors and I don't do coils, if you've seen some other videos, on the 3UZs, if you pull the coil out and the ECU detects a misfire, it actually shuts down the injector. So as I pull a coil off, it'll shut down the injector until I literally turn the ignition off and back on again and start it up. So if you're looking for a misfire, it's not ideal to pull the coils out, unfortunately, well actually the connectors, okay? Simply because if you do that, it'll shut the injector down and you're just going to create misfires as you go along, okay? Sometimes you can just loosen the bolts and lift it up, the actual coil itself, that's a way of doing it, but the easiest way is just to remove the injector plugs one by one and you should hopefully find where that misfire is located, okay? And then lastly, we're going to come back to the codes. Remember, the ECU is remapped for a manual application, so you'll see when we go to the codes, we've got 0 automatic gearbox codes, we've got no secondary Lambda codes, we've got no evap codes, all of that is now gone. Obviously we've increased the power slightly, the throttle response is much better, and so on. So that's what's involved in the remap over there. All right, so let's get into the first section, which is just the ignition one. So all I'm doing now is I'm taking my black with a red wire as per the layout section. I'm going to give that 12 volts, so bear with me a second. All right, so as I do that, you can hear the relays all clicking as everything's coming alive. So first thing we're going to test is the check engine light, and you've probably already seen, but there you go. There's my little LED in my fuse box to show that the check engine light is working, okay? And on the dash, we can see we've got our check engine light over there, so that is all 100%. All pressure light, well, we already know that that does work and that is coming through there and that is connected to the little boxes translating for us. So we'll check again when we start it up and we'll see that light go off. Alternator lights, there's my little LED with the pink and blue wire attached. I'm just going to move the light out of the way so you can see that is on. Again, we'll come back once it's started and you'll see that that light is gone off. OBD2, okay, so because these take absolutely ages to fire up, I'm just going to go into function, I'm going to go into system select, and as you can see there, LS430, okay, so that is all good. And obviously that's going to bring me on to my next test, which is going to be the fuel pump. So I'm just going to go back in to the data list over here. You can see also that we've got 51 degrees, 23 degrees on intake and 15% on throttle, so we are getting live data through there. But for the fuel pump, we're just going to test that over. So you'll see here we've got fuel pump relay and fuel pump. If you've watched our fuel pump video and how they work, you'll know what those two particular things mean, and you'll know that we're just testing the fuel pump over here. So as I go in, we're then just going to press the arrow and 1, 2, 3. And hopefully you can actually hear the fuel pump relay clicking. Hopefully in the background you can hear that fuel pump whirring away over there. So now I know that the ECU is controlling the fuel pump. Absolutely happy with that. We know all the wiring to the fuel pump is correct. Happy with that. Right, okay. So that is all of that we're going to test on with just the ignition on. So we're going to go to starter up now. So just a quick recap. We're doing starter, make sure the starter circuit works. The ACIS valve at the back here, all right. Tach signal, we'll come back, check the tach. We'll also check the oil, the check engine light, and the alternator light over there to make sure that they've gone off. Coolant temp, well, we can actually already see the coolant temp is raised off the needle there, so we know that's working. Drive by wire, just quickly rev the engine. You can actually hear the throttle already working over there. VVT-i solenoids, we're going to come back to our machine, test those two. We're going to go around, do all the injectors one by one, pull them off to make sure that it's misfiring when we pull them off, and then we'll come back and we will do all the codes. So for me, it's ear protection time. Okay, and I'm just going to continue to talk through the video because the GoPro does seem to pick up my voice even with the engine running in the background, as loud as it is. Right, so again, yellow with a red wire, we're just going to give it 12 volts, and 1, 2, 3. That works just fine. So let's go on to our VVT-i solenoids. So we're going to go into active test. We're going to go VVT-i control bank 1. And you can read in the bottom there basically what it's going to do. Alright, so now we're going to go through one by one. I'm going to start on this side here. So let's start at number 2. Number 4. Number 6. Number 8. Right, the other side. Number 1. Number 3. Number 5. Number 7. Right, fantastic. Okay, so those are all the injectors working exactly as they should do. We're now going to go to trouble codes. And you can see we have got absolutely 0 trouble codes on there. So you'll see as I'm pulling off the injectors, they're picking up the random misfire over there, so that's absolutely fine. I'm going to pull that off over there. Right, so now back to normal volume again. Right, perfect. Okay, so as you can see, we've got 0 actual codes on there. It has picked up, obviously, when I'm pulling the injectors out, that we are getting a misfire. So the system is working exactly as we would expect it to. So we're super happy with that. But as you can see, all of the lights went off. We've got no check engine light when she's running. So the check engine light system does work in its entirety. Obviously the beginning when it misfired, you can see I've not clipped all of the injectors in. They're just resting on there. So there's one just a little bit loose when I went to go crank it over. All right, so that's absolutely fine. Everything is perfect. Everything is exactly as it should be. So what we're going to do now, Gerard, is we're going to get this in a box. We're going to get it off to you so you can get your car up and running. If anybody else got any questions, again, please feel free, comment down below, or you can get us on our Facebook group. We try and get back to you all as quickly as we possibly can. Okay, but that's it, guys. And Gerard, let's get this off to you. Everyone else, thanks for watching. We'll be back again soon. Bye-bye.